Hello everyone. So we're going to continue with the question paper, and now we're starting off with question 4. Okay, the first question, part A, is asking me to do this integration to do between pi and 4 and 0. So pi and 4 and 0. What is the integral of cos x sine squared x dx? Now, if you ever see a question that has just a single cos or a single sine along with the other thing to the power of anything really, what you're going to end up, so what you need to do is ignore the cos, right? So ignore the single one. This is going to end up being something order of sine 3 to the x divided by 3, right? So you simply add 1 and divide by 3. Because remember, when I differentiate sine, I get cos. If this is a cos, when I differentiate cos, I get a sine, but obviously with a negative sign. Yeah, so and that's pretty much it as far as the integration goes. You put pi and 4 and 0. So remember the exact values of sine. So pi and 4 is going to be 1 on root 2. 1 root 2 cubed, all on 3. So we're going to end up getting 2 root 2 times 3 on 1, because remember sine 0 is 0, and this is going to finalize as 1 on 6 root 2. Okay, alright, part B. Okay, I need to show that cosec theta plus cot theta is equal to cot theta on 2. Now for this, so I need to show that the left hand side equals right hand side. But before I show you that, let me remind you of what sine, cos, and tan are in terms of tan theta on 2. So I'm going to say t is going to be tan theta on 2. All right. In that case, it turns out that these are things that you need to memorize. Sine theta is equal to 2t on 1 plus t squared. Cos theta is going to end up being 1 minus t squared on 1 plus t squared. And tan theta, now this one comes straight out of the double angle formula, but anyway, it's going to end up being 2t minus 2t on 1 minus t squared. Out of these three, I would say this is the most important one to remember, right? Because this is a double angle formula. Now, once you remember this, it's actually fairly easy to remember the other ones, because, put it this way, sine theta, the only thing that changes is the plus sign. So the denominator changes to a plus. In the cos theta, the plus sign is there, but it becomes a 1 minus t squared, right? So if you want to think about it, when I add these together, I get actually, never mind, don't worry about that. Okay, so just remember 1 minus t squared for cos theta, right? Okay, moving on. So cosec theta, so left hand side is going to be equal to cosec theta plus cot theta, right? Now remember, cosec is 1 on sine, and cot theta is cos on sine. So what I can do is take 1 on sine theta outside of this. So what I'm going to end up inside is going to be 1 plus cos theta, right? 1 plus cos theta. Now we substitute these things in, these values in, right? Those two. So the sine theta, remember it's flipped. It's going to be 1 plus t squared on 2t. And the 1 plus cos theta, it's going to become, so the 1 stays the same. It's going to become 1 minus t squared on 1 plus t squared. Right now, if you can see, like we're going to end up cancelling that off, but not just yet. So we're going to take this to the common denominator, and I will end up having 1 plus t squared on 2t. And over here it will be 1 plus t squared plus 1 minus t squared, right? All on 1 plus t squared, right? So So the 1 plus t squared is going to get cancelled out with that one. The t squared is going to get cancelled out with the minus t squared. Now I end up with 2 over here, right? So this 2 over here is going to get cancelled with that. So I end up with 1 on t. And remember, t is 1 on tan theta, theta on 2, which is equal to cot theta on 2. It's right, equal right hand side. Okay, so that's the end of that question. Okay, part B. Now part B is all about a parabola. Okay, they give you the equations of the normals and say x plus py is equal to 2ap plus ap cubed. Now that this is given to you, and they're saying that this is a normal to at a point P, right? At the point P, which is 2ap ap squared. Anyway, and similarly at point Q, it's going to be x plus qy is equal to 2aq plus aq cubed. Now, if you're struggling a bit with what a and q are, right? A is going to be the focus. Q, now q is just a parameter, all right? So this parametric parabolas. So I'll let you look into that yourself. But okay, so we have two equations, 1, 2. And if you have two equations to get the intersection point, that's what they're asking for part 1, to get the intersection point. It's really easy. You just simply do simultaneous equations. So what I'm going to do is going to go 1 minus 2. And I will end up with the x's cancel off. I will end up with p minus q times y, right? And then this part, it will be 2a p minus q. And then the last one, I will end up with 8 plus a times p cubed minus q cubed. Right, now this, you should straight away think, hey, that's the difference of cubed, right? So that's a little hint. The next step, I'm going to be dividing by p minus q. So this p, so that p minus q, the entire equation by p minus q, that's what I meant. So, and then the last one, okay, let me expand this out. When I divide this by this thing, the p cubed minus q cubed is going to be p minus q, p squared plus pq plus q squared, right? And all divided by p minus q. And of course, the p minus q's are going to cancel out again. And so we end up with 2a plus ap squared plus apq plus aq squared, right? Now I can simply take a out of this and say that it's p squared plus pq plus q squared plus 2. Okay, so that's a y value. Now to get the x value, I need to substitute this back into an equation. So I'm going to substitute this back. So let's call this equation 3. I'm going to sub in 3 into say 2. You can take a pick, right? So what I will end up having is x plus x. So I'm going to take qy to the other side straight away. I'm not going to mess around. So I will have q times y. So y, I'm going to substitute this one this time. Alright, so it's going to be 2a plus ap squared, yada yada yada, and I will end up with plus 2aq plus aq cubed. Yeah, oh sorry, this is supposed to be minus of q, right? Okay, actually I probably should have written that yada yada thing out, so I will write it out. So it's going to be ap squared plus apq the last one is aq squared plus plus aq squared. Now if you look at this, now if I multiply the inside, right, I will have a minus aq cubed over there, right? And I have aq cubed right there. So this term is going to cancel out with this one. When I multiply those two, I have a minus 2aq, which is going to cancel out with that. So that's going to cancel out with that. Alright, so what I'm going to end up with is, so I'm going to leave the minus q outside, and I'm going to take whatever the common things are. So it's going to be ap. So that's apq there, ap squared. So I'm going to take another ap outside, so I'll have minus apq times, inside it would be simply p plus q. Alright, so there you go. So you have your x and y coordinates. Okay, you should write this out separately in the next line, right? But I'm going to let you do that. Okay, part two. Part two. They told you that y is equal to half p plus q x minus apq is the equation of a chord. Now that's given to you. They tell you not to show that, right? They're saying if this chord passes through the point 0, a, prove that pq is equal to -1. To do that is a simple matter of subbing it in. So I will have a is equal to this entire term disappears because of 0 is equal to minus apq. So dividing through by minus a, I guess, I will end up having pq is equal to -1. Okay, and that's it to that question. It was just a 1 marker, so it was fairly easy. Okay, now this point that I found out in part 1, they call that point R. Okay, so this thing and this thing is point R. So what they want you to do is find the equation of R given that the chord passes through 0a, right? So given that the chord PQ passes through 0a, they want you to find the equation of, or the locus of R. So let me rewrite this. X is equal to minus apq plus p plus q, and I have y is equal to a times p squared plus pq plus q squared plus 2, right? And remember, because pq passes through 0a, I know that pq is equal to -1. Now that's the big hint. All right, now I can substitute this value in here and also into here. So I will have x is equal to, so that's going to become a plus a times p plus q, excuse me. Y is equal to a times p squared plus q squared minus 1 plus 2. Right? So this is equal to a times p squared plus q squared plus 1. Right? Okay, good. Okay. Now, what I'm going to do, I'm going to call this equation 1, equation 2. What I'm going to do is sort of square 1, right? So I'm going to divide through by a and then square it. So I will have x squared divided by a squared is equal to p squared plus q squared plus 2pq, right? Now remember, 2pq is equal to -2. So I can rewrite this as going p squared plus q squared minus 2. Okay, now with 2, with this equation, I would rewrite this and go y is equal to a times p squared plus q squared minus 2. Okay, so I introduce a -2, and we'll go plus 2 to get rid of it, and go plus 1. Okay, now this part of it is simply that. Yeah, so I will have a times x squared on a squared plus 3. So the final equation, my final equation is going to be y is equal to x squared on a plus 3a. Okay, alright, there you go. Alright, so I'm not going to do part D just yet because we ran out of time, but if you have any questions, leave any comments and let me know. Thank you.